Hey guys, I'm Ben Corrado. I'm the CEO here at NerdNode and DeEEP. I've got Lynn Duke with me today, and he's our head of engineering. We're going to spend some time today talking to you guys about the testnet, what phase we're in right now, and a bit about how we've really taken a lot of time to build out the security pieces and the orchestration layers on the DeEEP Testnet, and what that looks like as we kind of roll towards Mainnet. So Lynn, we've been working on testnet for a while now, and I think we're on like our third or fourth iteration, and we're finally kind of narrowing down on like the final release, and I think we're in a pretty exciting spot right now. Do you want to tell our viewers a little bit about, kind of over the last week, kind of the big milestone that we just hit with real DeEEP devices?
It is pretty exciting. We've rolled out what we call the Midnight Testnet. We've rolled out a bunch of mock workloads that do a bunch of structured testing for us. So we test, and what we tell people all the time is we don't always control the software, the quality of the software, and how it's written. So we have to make sure that we do enough structured testing to handle and be resilient to conditions we see in the network.
Yeah, so when you're talking about the software we can't control, you're talking about the third-party nodes that we're running for other people, right? And so
that's right.
Sometimes that quality of that software, it hasn't been super well tested. It might be super early, or it just doesn't run very reliably. Is what we found with some of these nodes. Some of them are great, some of them aren't, right? So tell us a little bit about how the team has helped solve some of those issues, right? Of how unreliable node software, how do we make it reliable?
So I guess we could talk a little bit about what some of the issues we see are. So this could be anything from, ideally you want a healthy piece of software that just runs and does what it needs to do. But you'll often see kind of what we call unhealthy workloads. They could be running out of memory, or they could have slow starts, or maybe they're not reporting status to all of the interfaces in the DeEEP network that we really need to. So maybe their pings are slow, or they're not pinging at all. So what we really focus on is building software that will help pull humans out of this diagnose and relaunch, diagnose and relaunch loop.
Yeah, and when we're working on Midnight, tell the group a little bit about what Midnight Testnet is, and what are your goals for the Midnight Testnet, and where'd you come up with the name?
What? The name. Okay, are you serious?
Yeah, I'm serious.
Dude, okay, hold on. Midnight's a play on words. So it actually refers to the level of ocean water that is right above the floor of the ocean, but before sunlight actually reaches it. So midnight is actually broken to a few. There's midnight, there's twilight above that, and so we adopted that as sort of the first testnet name.
And these are like levels of the ocean. Like if you're down at the Mariana Trench, the bottom is the midnight zone, right?
Well, actually, the trench is the first official level. They call it the trench. Right?
Okay.
It's not specific.
Yeah.
The trench, so it's a crust trench. Midnight's actually the first bit of water you see. Zero, sunlight reaches that, and then twilight and so on. So really the idea behind Midnight is that we could take some arbitrary workload, right? We can throw it out on the testnet and let it soak some period of time and learn sort of what the performance characteristics of the workload are. Maybe some idiosyncrasies with the workload that you'd only discover by letting it soak on the network for some amount of time. And Midnight has enough capacity where we can throw these workloads out there and let them soak for days on end. And then through time series tracking, we can understand what they needed to stay healthy throughout that entire period of time. Yeah. That's one of them. Additionally, it also lets us kind of back up and, while those things are soaking, sort of flesh out tooling and observability metrics for things that we care about.
Yeah.
So we can find the signal and noise and then build interfaces around those so that when a human is involved in diagnosing these things, it's quick, it's easy, it's painless.
When I come and sign up for a node on DeEEP Network, these features that you're talking about, it sounds like they're going to give me things like I can click it, and then what am I going to see? Will I be able to see any of the things that you're talking about as a user of DeEEP Network?
Yeah, so the same observability that we build for ourselves, we hope to extend to users as well. And there's several layers of observability that matter. Some of those are very general to just health. Is my node up? Is it down? Was it up while I was sleeping? And then we can also sort of model behaviors and extract those, condense those down, and present them to the user in a very consumable format.
Yeah.
Some of the time series stuff that we've been talking about is an example of that. But ultimately, the goal is, the user doesn't have to care.
Right.
The node runs. The network manages it. If, for example, a node in DeEEP Network becomes unhealthy or unable to fulfill its duties, we can move the Web3 node software to another healthy node.
Yeah.
And the user doesn't have to be aware of that. But it would be nice to let them know that those are the types of things that have been happening to that workload.
Right. Yeah, so if I own a DeEEP device in my house, you'll let me know that something was wrong with it, and you'll automatically move workloads off of it so that the people who are paying the DeEEP network to run that don't get penalized.
That's right.
But then you'll give me an alert that, hey, your power went out or your internet went out or something's wrong with your device. Contact us for support. Is that what you're saying?
Yeah,
okay.
that's right.
Yeah,
Yeah.
that makes sense. We've got Midnight. What is the step after Midnight? What does it look like to move out of testnet for DeEEP Network?
Yeah, so Midnight's really a proving ground, right? It's where workloads go to prove themselves. You can think of it as a gauntlet. And so once we've established enough time in testnet and we know that a workload's truly ready for production, we advance that to what we call the Twilight Network. And again, back to the play on words, Twilight is the level of water where sunlight begins to reach. So it sort of represents it coming out to the world in the sense of production-ready workload.
Yep.
At that point, we understand everything about the node, what it takes to run it. We understand its memory footprint characteristics, performance characteristics, etc. And so that container or that Web3 workload can be migrated to Twilight very quickly and easily and finds a home in the production stack.
So when a new workload comes out, new node type that somebody wants to be able to run on DeEEP Network, how do you anticipate that transition happening, right? Of, hey, brand new piece of software, nobody's ever run it before, just came out, brand new node. How does that get on DeEEP Network? How do you make sure that it can run reliably, that we can capture the right secrets? Like, what does that process flow look like, and how do you validate it before we say, yep, checkbox, ready to ship to production?
Well, I think that comes back to the Midnight gauntlet that we were speaking about earlier, where there are a series of tests that this workload has to pass through. We talked about performance characteristics and running footprint and uptime and tracking those things through time series. But this is all automated. So outside of a human actually putting the workload into the Midnight Testnet, it's completely hands-free. It'll run for some set amount of time, and we'll collect that data, be able to analyze it, and determine its worthiness for moving on to the production network.
Cool.
So Midnight, I've had a blast. Twilight, making these testnets a reality. It's been a lot of fun over the last several weeks. I was wondering if you could talk a little bit about how that meshes with the security approach that we've had for the entire duration of the DeEEP network, through its planning and its eventual rollout, and how do those things play with each other?
It's a huge question, right? And we really have spent a lot of time on security here at DeEEP Network, and it's really been the forefront of what we think will differentiate our network versus most others right now is the security layers that we have in place. And we know that all blockchain is based around cryptography, right? I mean, that is the basic stance of why we call it crypto. It's all cryptography, right? But if we look at most DePINs, most node as a service solutions, there's almost no cryptographic security running on any of these devices, right? The secrets get injected usually in plain text. Yeah, maybe they're stored at rest in a secure vault, but ultimately they have to get onto a physical device somehow, and then they have to be run. And most of these physical devices provide little to no security in place to protect those secrets or the data that's associated with what those secrets unlock, right? So at DeEEP, we've focused on building hardware that has security forward principles. So we take advantage of what's called a trusted platform module that is embedded in each device. And that enables us to do secure boot. And we have locked down our hardware to only be able to boot OS images that are signed and released by our team, right? And that's those keys are stored on a hardware security module in our offices that require PIN codes to unlock, so not anybody can just steal them, right? So we've really focused on like how do we do the boot level security first, right? Because if you can break your boot level security, game over, right? Then the next piece we focused on is runtime security. One of the big problems that you can find in runtime security is memory. We put all kinds of things as programmers into memory in our computer systems. And it's not too difficult to warm boot up a computer if you don't have secure boot and steal things out of memory that way. You can also like put a computer in liquid nitrogen, pull the RAM out, pop it in another computer in liquid nitrogen, turn it back on, and pull all the memory out of the RAM, right? And these types of attacks require physical access, right? Well, DePIN, it's sitting in somebody's home, somebody that we may or may not have KYC'd, but we certainly don't trust with anybody's data that might have it, right? Like just because we know who they are doesn't mean they're trustworthy. And so being able to pull that data out and those keys out can open up the whole vault of everything that our customers might be running on these devices. And it makes these networks not trustworthy. Well, at DeEEP, we've built hardware that runs encrypted RAM. So every boot process, there are scrambled keys that are stored inside the processor temporarily for each boot cycle, and it creates a key for the RAM, and it gets AES 256 encrypted up to all the RAM. So we've got encrypted RAM to protect runtime from those types of attacks. Then you have to worry about your hard disk, right? And so we've done a couple things on the disk side of it. We have secure file systems that store our temporary data. And this is the data that all the nodes, they have access to this drive, and they get individual volumes on this drive, so they can't access multiple pieces. But all that data is encrypted, and it's unlocked using that TPM. And it's based on, the TPM does an analysis at boot. Did it boot up the correct way that it was appropriately signed to boot up to? And we use what's called an immutable file system on our core that if you edit a single bit in the file system, it won't boot. And then we've got four backups, behind that we've got 5 different ways to boot. That if one of those bits gets flopped on accident, it'll fail back to a B version of the boot, then it'll fail back to a recovery version of the boot, and then it'll fall back to a reset version of the boot, and then there's a way to plug in a USB stick with a signed bootloader and boot a whole new version. Nice. So we built a lot of redundancy into that, but it also affords a lot of security in that nobody can go and modify any of those contents. So we know coming up we can analyze the contents of the drive, make sure they're appropriate, unlock that partition that has all the customer data on it. And then we have another partition that has all the secrets about the device. So it contains your serial number information. We've got some of the temporary keys that get rotated on a regular basis for how do we access the network and that type of stuff that live in this drive. And very, very heavily restricted what programs can access that, as well as it's encrypted with a whole nother key that's different from that first key. Uses that same mechanism to unlock. That's before we get to even running any workloads. So now we get a workload order. The device gets a workload order from your side of the camp that's like, hey, we need you to run this node, and you pass down the instructions of what to run. Mm-hmm. So basically it's a file that tells us how to run it with the orchestration, and secrets that come along with that, right? And those secrets get injected, and what we're working on right now is making it so that those secrets travel and traverse the whole network, encrypted by the TPM key. So this is a piece we're actively working on. It's not fully implemented yet, but we're hoping by the end of the year we'll have end-to-end fully encrypted with hardware encryption from an HSM, the hardware security module that is running at one of the managed orchestration servers. So a handful of DeEEP devices in the DeEEP network will be orchestration servers. The TPMs in there will hold those keys. And then the leader of that, which gets voted on by the network, it votes in the leader, will then be able to take, using its TPM, encrypt that secret only for the device that's supposed to be running it with the public key of that device, send it down through the VPNs and public internet down to the device that's supposed to be running it. That will then take that into its TPM, decrypt it, and inject it onto the actual running workload. So we'll be able to have kind of end-to-end security there, as well as all of the VMs and containers that we run are non-privileged. So the volumes that we create for them cannot be accessed across containers. And we can also separate the memory spaces. So all of this creates a lot of different places that we can secure customer data information. It gives us secure element in a TPM that we can protect keys and store our customers' information reliably and confidentially. And we can provably show that these end-to-end links are hardware linked, encrypted methods to keep their secrets safe.
Nice. Yeah, that's quite a bit. So
it's quite a bit.
Heavily siloed. They're great silos to protect any kind of pollution or cross-contamination of sensitive data between these silos.
Yeah. And this is an area that we've thought a lot about at DeEEP Network. It kind of comes down to where does it matter, right? Mm-hmm. Some nodes, it matters a lot. If that node is storing personal data, if it's storing, anything about finances, health data, maybe even just your pictures of your kids that you don't want, other people being able to get access to, right? Those can live in higher security level zones in the network. And then we're also looking at, what about the ones that are cryptographically safe in that they can run in completely untrusted environments? Well, we might be able to save cost on those by putting them in a less secure zone of the device, basically, that lets it share memory spaces with other things. So we're kind of exploring that transition of very secure bank level style security, which we think we can get to with the hardware that we have, all the way down to it doesn't really matter. And so we can pile a bunch of this over on these types of devices. And so we'll end up with devices in the network where it might only run one type of node that needs to be very secure because we can guarantee that level of security, right? And others might share hundreds of different things. And the cost associated with those will be different because the security levels are different, right?
Right. And our system will be intelligent enough to know the difference.
Yeah.
Where those things can run, where they cannot run.
Yeah.
Great.
Yeah, and one of the things that, as you know, Lynn, we've been working on quite a bit is how do we create what we're calling affinities and requirements, right?
Right.
So if something is legally required to run, like Germany has a lot of privacy laws, for instance, and if you're collecting user data in Germany, oftentimes it can't exit, maybe even Germany, but certainly not the European Union, right? Because the laws there are just different than they are here in the States. And so we need to be able to say with a high level of confidence that these devices are in the European Union and they're subject to GDPR compliant processes, right? And so we'll be able to set hard requirements that say, okay, this has to run in the European Union, right? And our customers that build nodes will be able to tell us, these requirements, these hard requirements. But we can also do what we call an affinity of, if you're running a game server and you bought a game server and you live in the Netherlands, and you say, I want to run this on a node in the Netherlands so it's as fast as possible for me. But if there isn't a node in the Netherlands that can run it, I want it to run somewhere, right? And so we'll create an affinity that says, okay, put it here. But if it can't run here, run it somewhere else that's nearby, right? So we're building out these kind of like tight rules and loose rules around how we assign workloads in the network to make sure that whether it's geography, IP addresses, ports, some nodes aren't compatible with other types of nodes. They just can't run on the same types of systems, or they use one node will need a GPU and we'll use the whole GPU and you can't share it with anything else. And so we have a hard requirement, requires GPU, and no other devices on that system can use the GPU, right? And so we're building out these rule sets around how do we make sure that when somebody hires DeEEP Network to run a node for them, well, that can get pushed out to the appropriate type of device that's well suited for it. And depending on different regulatory requirements or customer requirements, if they say it needs to run here, we could say under like an SLA, for instance, yeah, it will run here, or it won't run. Or they can say we would prefer it run here, but it could run at other places, right? And so working on a whole bunch of different cool pieces like that kind of, it's security adjacent, right? Of, the EU looks at that geographic piece as a security mechanism, right? And so it kind of falls into that bucket. Well, Lynn, thank you a ton for taking the time today to talk with me and to talk with all our viewers about what we're doing here. I think we need to do these more regularly.
Definitely.
And as we're really getting out and moving towards Mainnet, the pace has just picked up so fast. And I know we've been so heads down. My apologies to everybody out in the community that we have not been doing these communications as often. But it's exciting to get to show you a little bit about what's behind the scenes. And I think we've got some more pieces coming there. As many of you guys have probably seen, we've been sold out of our 1776 devices for a while now. We've got the DIN NFTs available on our website. Make sure you go check those out. This is an opportunity to get front of the line for the next set of hardware and to make sure you're getting the maximum rewards that you can as a participant in the network. Make sure that you're hitting that like button, subscribing, and following all the updates that we're putting out there. We'll have a bunch coming out in the next couple weeks, and thanks again for joining in, and hope to see you soon.